you need to have your notes open in Kami like you normally do. But then also when you go to your notes in Schoology, and here's where you open assignment with Kami, there's a link right here. You also need to click on this link, and it's going to ask you, do you want to make a copy? So yes, you want to make a copy. So you click on that. You click on that. My board doesn't like me. Hopefully when you click on it, something happens. Maybe I've made too many copies and it doesn't like it. Let me try again. Oh, no, it's just thinking. Now I've probably made like 10 copies. I didn't think anything was happening. And it might take a minute for like the whole thing to load. It's taking a minute. Okay. So it should look something. It'll look like this. This isn't it. You just got to give it a second. Get it all loaded. And if it asks you to dismiss, if your controls are hidden, I don't know if it will. I thought it would pop up in the settings that I had, but I think it's popping up however you had your Google Docs settings before. So if you have a bunch of like file, edit, all that stuff up here, and you would like for this to be a little bit bigger, if you go to view at the bottom, it's full screen. And then if that's what I'm in right now, is full screen mode. And then this rectangle will actually take up on your tablet like the whole thing. I just have a different setting up here. Okay, so have this open and have your notes open. We're actually going to start in the notes, but I want to make sure that, does everybody understand what to do with this? And we got it open? Okay. So we're going to start here, and then we're going to move over there. But I've got to, my Zoom stuff gets in the way and doesn't hide itself anymore, and I can't change there we go. Okay. So mine's really big right now just because I want to focus on a couple of things, but I'll shrink it where you can see the whole thing. But here are your notes, okay? So today we are going to start talking about the unit circle. I cannot stress to you how important it is to know your unit circle, all right? And don't freak out today if you're like, oh my gosh, this is so much information, because I have things we're going to, it's kind of a gradual. I'm going to give you tons of information today, and then we're going to talk about how you organize it in your brain, how you pull it out of your brain, things to help you remember all that stuff. But first, a unit circle means that the radius is 1. Okay, so your unit circle has a radius of 1. That's what makes it a unit circle. 1 unit of whatever unit it is. And on this unit circle, we are using our special right triangles, which we already know. That's like totally old business. And so if I look at this 45, 45, 90 triangle, and we know if we want to solve something, we would label this L squared of 2. The other day, we were trying to come up with ratios, our trig ratios, so instead of the L's, we used 1, 1, and 1 squared of 2, or just squared of 2. Okay? Now, there's absolutely nothing wrong with that. That's legit. That could help me solve stuff. And I could make these side links whatever, as long as the ratio in the end was the same when it reduces down. So what I want here, in this 45, 45, 90 triangle, my hypotenuse to be 1. So if my hypotenuse is 1, to get from the square root of 2 to 1, I would divide by the square root of 2. Make sense? So as long as I divide every side by the square root of 2, it has the same ratio, everything's good. So this 1, if I divide it by the square root of 2, I get 1 over the square root of 2. When I rationalize that, what is it? Square root of 2 over 2. Okay, so that makes this side square root of 2 over 2. It's an isosceles triangle, so this is square root of 2 over 2. Both of these are completely correct, legit ways to label these triangles. However, for the unit circle and for what we're doing, we want to think about it this way. So I'm going to put an X through this, not because it's wrong, but just because it's not what I'm using right now. Okay? Everybody with me so far? All right, so now let's look at 30, 60, 90. If I was going to label it to solve, I would have S, 2S, and S squared of 3. So the other day when we were coming up with ratios, we made that 1, 2, and the square root of 3, basically just saying S is 1. So again, completely correct, fine way to do things, but I want the hypotenuse to be 1. So if the hypotenuse is 1, I divided by 2 to get there, so I'm going to have to divide each side by 2. That makes this one 1/2, and this one square root of 3 over 2. And then I'm going to put an X through that one. Any questions at all at this point? Okay. So now I want you to look at this unit circle kind of as a whole before we move on to the activity. Look at the angle measures that we have. Okay, I have them in degrees and in radians. And after today, we're really going to stop talking about degrees so much. And if you look at this, notice that the numbers, I mean, they just get bigger and bigger and bigger when you're looking at the degrees. Same thing happens with the radians, but do you see how the denominators repeat themselves? Okay, you've got 3, 4, and 6. That's it, 3, 4, and 6. And so we're going to be able to see some patterns in there, and it's really, really going to help us with that. We only care about knowing and understanding, I don't like the word memorizing, but knowing off the top of our heads our special angles. So like on Monday, I think drew an angle, or we converted, one of them was negative 11 pi ninths. So 11 pi ninths is a legit angle that could be on a circle. It could even be on a unit circle. It's just not a special value that it's important for me to just know, okay? So it's very limited in what we're expected to know and understand. Okay? Now we're going to come back to this and fill some other stuff in after we do the activity. So let's look at the activity. So here's some good news, bad news stuff here before you start doing anything with this. I had to do this in Google Slides because I wanted you to be able to move stuff around and not have to create stuff yourself. It seems like, and it would make sense, that it would be really easy with a touch screen to move with your finger or move with your stylus. That isn't necessarily the case for everybody. I don't really know why. It was much easier for me, surprisingly, to move it with my mouse. Just because I don't know why, really. If you accidentally, because I couldn't lock this stuff, if you accidentally make something bigger instead of moving it, or you move just part, because like all of these things are grouped, if you move just part of things when I tell you to move them, Control Z is your best friend. It's undo. Just undo and you're back to where you were, and it's fine, okay? If you want to use the mouse, your touchpad's fine, but I have real mice up here too if that makes it a little bit easier for you. So, sorry. I mean, you can try it with your finger and with your stylus. I just don't know how well that's going to work for you, unfortunately. All right, so we're on slide 1. So what we're going to do over here is we're going to come up with all these empty ordered pairs that we have. I will explain to you before we leave today why we even care about the ordered pairs. You have to just trust me right now that we do care, and it's important. And we're going to start with this one, so don't get ahead of me just yet. So this ordered pair here where the angle is 0 or 2 pi. What do you think, this being a unit circle, what do you think this ordered pair would be? What? 1, 0. Because if it's a unit circle, your radius is 1. That's your radius, right? So this has to be 1, 0. So grab the 1, put it in the X spot. Grab the 0, put it in the Y spot. Now, I know that you know the difference between X and Y. At least you should. But lots of people get these mixed up, so make sure you're really thinking about this. Now we're going to move to pi halves. What is the ordered pair here for pi halves? What do you think that would be? This is still the radius, so this would have to be what? Not 1, 0. Your X value, you don't go left to right at all. Your X value is 0. Your Y value is 1. Then we're going to move on to pi. What would this ordered pair have to be? Negative 1, 0. Yes. And then we move on to 3 pi halves, and that would have to be 0, negative 1. Everybody with me so far? Okay, so these 4 green triangles that you have here, these are all 30, 60, 90 triangles. I already have them labeled with the side links and just the 30-degree angle. The Roman numerals that are in there, those are the quadrants that we're in. So I want you to grab the quadrant 1 triangle, slide it over to quadrant 1, and right here you see how you've got this 30 degrees or pi 6. You're going to put this right there where the 30-degree vertex is at the origin. Last period, I accidentally just dragged a triangle once instead of like the whole thing, and that's because if you like click on it and then click and drag, you could just move a piece. So just, again, Control Z and then grab it differently and you're good. Okay, so I just want you to have one triangle on there right now. Okay, and I'm trying to kind of read the room to know that I've given you enough time. So if I move on and you're like, wait, I haven't got my triangle there, just let me know, okay? So we have this green triangle here now, right? This is my 30, 60, 90 triangle. So this angle right here is pi 6. This vertex here is at this ordered pair. I'm sorry, it's at this point. So I want to use this information in my green triangle for this ordered pair. So look at what you have and think about it for a second. Think about what do you think this ordered pair right here would have to be? 1/1/2. Okay, so why the 1/2 for the y value? Because this is how far you go up, right? Okay, so 1/2 for the y value, I agree with that. Did I go over 1 to get to the x value? No, how far did you go over for x? Square root of 3 over 2, right? Because that's how we graph things, x, y, right? Here are my answers right here. This is the x value, this is the y value. So your x value is the square root of 3 over 2, your y value is 1/2. It comes from that triangle, okay? So let's grab a square root of 3 over 2, drag it over to our x value, grab a 1/2, drag it over to our y value. And I know that my circle and everything is very hard for you to see. It's actually kind of hard for me to read up here, but you have yours in front of you, so hopefully we're doing okay here. Any questions at this point? Because remember, 1 is the radius, so this hypotenuse is 1. This distance is 1. This distance is the square root of 3 over 2. This distance is 1/2. So let's grab our second quadrant triangle and plop it down. All right, so what do you think the x value for that ordered pair is? Negative square root of 3 over 2. Very good. This is still a positive because it's a side length, but when you're on the coordinate plane, we're going to the left here, so that is a negative square root of 3 over 2, and the y value is 1/2. So let's take a negative square root of 3 over 2, plop that down, and a positive 1/2. And I apologize if the little parentheses don't really work very well to put these in there, right? Or you lose a comma or something. Once I realized that I needed to make them bigger, it was way too difficult to actually change the little parentheses, and so I just left it. And there's not an easy way for you to write on, for everybody to be able to write on this. All right, so let's grab our Roman numeral 3, put him in there. So that means now that my x value is still negative 3 over 2. I'm sorry, negative square root of 3 over 2. And my y value is now a negative 1/2 because I'm in the third quadrant. Once you've got that, go ahead and put your fourth quadrant triangle on there and fill in your ordered pair. And then don't move on to the next or anything. We got lots to talk about here. Okay, so there's a couple of things I want you to recognize here. If I was talking degrees, I have 30, 150, 210, and 330, right? Not complicated numbers, pretty easy to figure out, but they aren't really obviously visually related to each other. Where here, I have pi 6, 5 pi 6, 7 pi 6, and 11 pi 6, right? They're all my pi 6 angles. One of the things, and again, there's going to be lots of different ways that I show you to visualize and bring all this together, and you know, people's brains work differently than other people, so some of you, it's going to be really easy for you to kind of close your eyes and you can kind of visualize things. So even if that's not necessarily you, I still want you to see how all of the pi 6th angles are the ones that are closest to the x-axis. Okay, and really, in theory, we could have one triangle And I started to do it this way, but I didn't want the reflection thing on here to be too difficult. So I could have just given you one triangle, had you reflect it and put it down, and had you reflect it again and reflect it again, and they're all the same, okay? The other thing is pi sixth, 5 pi sixth, 7 pi sixth, 11 pi sixth. Tell me, how is pi sixth related to each one of them? What kind of angle is it in relation to 5 pi 6, 7 pi 6, 11 pi 6? What did we talk about on Monday? Starts with an R. Reference angle, okay? So when I ask you questions about 7 pi 6, your reference angle is pi 6. So as long as you know everything you need to know about pi 6, you can relate it to 7 pi 6. You just have to know that that's in the third quadrant. Okay, those reference angles, much easier to figure out with radians as well, because anything with a 6 in the denominator, pi 6 is your reference angle. Okay, we're all good so far? See how those green ones work like a little butterfly? Any questions? All right, I want you to go to the second slide and just fill in your 4 quadrantal ordered pairs and stop. Okay, you might have to move this triangle over a little bit. Fill in these 4 ordered pairs on your quadrantals and then stop for me. I know some of you are still dragging and dropping, but would you say value-wise, these are pretty easy to figure out and understand, right? Because we know the difference between x and y and it's no big deal. Well, believe it or not, when I start asking you for values from these ordered pairs, these are the ones that people have the most difficulty with and get the most mixed up. So that's why we're going to have to do them over and over again on each slide, because I want you to really think about it. Again, I know you know the difference between x and y, but sometimes those things get a little mixed up in your brain. Or not mixed up, but you say the wrong thing or whatever. All right, so we're going to look at the pi 4th angles now, which is our 45. So I want you to grab your Roman numeral 1, your first quadrant triangle, and place it like so. And then this is an isosceles right triangle, so the x and the y are exactly the same. So the one that has the 2 coordinates the same has a square root of 2 in it and not a square root of 3. So that means my x value is square root of 2 over 2. My y value is square root of 2 over 2. Everybody good so far? All right, so pi 4ths, my pi 4ths angles, pi 4ths, 3 pi 4ths, 5 pi 4ths, 7 pi 4ths. Remember when I said you need to be able to think fractionally around the circle? You can think about each fourth. So this is pi 4ths. This is 2 pi 4ths, which becomes pi halves. Then 3 pi 4ths. Then this is 4 pi 4ths, 5 pi 4ths. This is actually 6 pi 4ths before it reduces. Then 7 pi 4ths. Then 8 pi 4ths. So you can think in fourths there. All right, so let's take our second quadrant triangle and plop it down where it goes. Now, I'm very limited to what my choices even are here, right? So now I just have to understand what's going on in the second quadrant. My x value should be negative, so I have a negative square root of 2 over 2, and a positive square root of 2 over 2 for the y value. And then go ahead and plop your next 2 triangles down there and fill those in. And then we'll talk about this one a little bit. So I want you to see and think about these triangles as reflections, all of just the first quadrant triangle. If this was any other school year, this is what we would be doing today with our triangles and literally reflecting them so that you could see them. but I can't give you paper and we can't cut and have fun and stuff. So I did the best I could with a digital one, but this is something that people always had open in their ISN, like always, because it's going to be very helpful to you. So I'm going to make sure you know how to get back to this as well. So again, you see your pi fourths and how this just reflects down here. All 4 of these ordered pairs, the absolute value of the number is exactly the same. The only thing you have to keep up with is the signs to know because of the quadrants. So if I asked you about this one right here, which is 5 pi fourths, then if I said, you know, what is the y value when you have 5 pi fourths, which is not how I would ask it, but we'll get there in just a minute, then you know it's going to be square root of 2 over 2, and then you just have to decide what quadrant that's in when you think, oh yeah, that's a quadrant 3, so that means that my y value is negative. And those little thoughts, you'll be able to process through that pretty quickly. Okay? Any questions at all? All right. Then go ahead and on this one, I think you get the hang of it, so I want you to try and fill this one out, the whole thing, all by yourself. Okay? I'll give you a minute to do that. If you have questions or you're not sure what I mean, let me know now so you're not just sitting there. Are we all good doing it on our own? I will take that as a yes. Oops. Did I give you enough time for you to click and get them there? All right, so just to make sure, in case you can't read this, that this first one should be your x value is 1/2 and then square root of 3 over 2. You just repeat that and then make sure your signs match the quadrants. Are we good? All right, so now I want you to click, we're on the third slide. I want you to click back to the first slide and then back to the third slide. And as you click back and forth, do you notice how the x and y values have just switched places, right? Because this is a 30, 60, 90 triangle, so the side lengths are the same in both triangles. It's just which one is, you know, the x and which one is the y is what switches. So you're very limited to, again, how many different numbers you even have. And when you're trying to keep track of these two, if you can picture it on the circle and you're trying to figure out this ordered pair here, well, this is my pi sixth one right here, right? Well, clearly the x value has to be bigger because I have to go further to the right to get that x value, where I don't have to go as far for the 61 here, or for the pi thirds. And so that should help you keep track of which order to put it in, if you think about where it goes on the circle. Okay. Any questions at all? All right. Let's go to slide 4. So I want you to take your green triangle, put it on in the first quadrant, then take your pink triangle, put it right on top of it, and then take your yellow triangle and put it right on top of that. And then if you wanted to, and you know how all the little functions work, and you wanted to actually reflect them to the other quadrants or whatever, you can. I mean, this is yours. You can do whatever you want with it. But after you get that on there, then I want you to take all of this information and put it all on the circle at once, right? So I know it's a lot of clicking and dragging, but and if you accidentally make it bigger, just Control Z and undo it. Any questions on what to do? Does anybody need assistance in it, or you just need time to do it? Okay. I know the dragging and dropping is tedious. This is the last time you'll have to drag and drop all these numbers. I just couldn't find an easy way for everybody to be able to write on this. So you'll get there. It's all good. I will tell you, though, like I said, that foldable that we would normally do has kind of turned into this. But I kind of like it that you can see over here even that, you know, how they work together. But it is something that students often have open in front of them to help them. And so as I'm trying to help you get digitally organized, I believe when I had you do that last Friday, I only had you do units 1, 2, and 3 folders, but go ahead and create a unit 4 folder and start putting stuff in there. When you created a copy of this, it put a copy into your Google Drive. It's just not in the Kami or Schoology assignments because you're not actually like turning it in, but it is in your Google Drive. So to find it easy, you could always just put it in that Unit 4 folder because that's where I want it to be eventually anyway. Okay, I'll give you another minute or so to get them dragged and dropped. Please let me know if you're confused or this doesn't make any sense or anything. You just need drag and drop time, which is fine. And if you're finished dragging and dropping, just look at it as a whole and look at these numbers, look at the patterns that you can see yourself, and then we'll talk about them. Look at the degrees, look at the radians. See why maybe I'm saying the radians in the end are going to be a whole lot easier for you to comprehend and remember and relate to what we're doing. And then when you are done with all that, we're going to go back to the notes. Is everybody done dragging and dropping? Okay. All right, so we're going to go here. And so and you can keep the other one open, but without looking at that, we are going to fill this in, but we're going to fill it in together because we're going to fill it in a specific order this time, and then you can decide how, it makes more sense for you to fill it all in. You won't be always filling in the whole thing. Sometimes you're just thinking about pieces, so it's important to know that too. But let's start by filling in the ordered pairs for our quadrantal angles. So remember, since your radius is 1, that makes this 1, 0. At pi halves, I'm at 0, 1. At pi, negative 1, 0. And at 3 pi halves, 0, negative 1. Goodness. Sorry. My finger's never on. And again, those should hopefully be the easiest ones for you to fill in. But once I start asking you information about it, it's the ones that people have the most trouble with for some reason. So just make sure that you can understand where they are on the circle. All right, so then let's start with pi sixths. If I have pi sixths or pi thirds, my two numbers are square root of 3 over 2 and 1/2. You got to make sure you have them in the right order and that you have your signs correct. So if it's pi sixths, your x value has to be bigger. So my x value is square root of 3 over 2. That means my y value has to be 1/2. So if I fill in all my pi sixth angles, those numbers get repeated 3 more times. I just have to have my signs correct. So in quadrant 2, x value is negative. So this is negative square root of 3 over 2, positive 1/2. In quadrant 3, x and y are both negative. So it's negative square root of 3 over 2, negative 1/2. And now that you're in Cami, it should be a little bit easier to write. And then in quadrant 4, be square root of 3 over 2, negative 1/2. Because you won't always have a finite number to drag from. We've got to keep them straight. When you get to all of your pi fourths angles, the x and the y value are the same, and it's square root of 2 over 2. So square root of 2 over 2, square root of 2 over 2, and then again, you just got to get your signs correct. In quadrant 2, negative square root of 2 over 2, positive square root of 2 over 2. In quadrant 3, negative, negative. In quadrant 4, positive, negative. And then you go ahead and fill in your pi thirds. Any questions at all about any of that? I know some of y'all are still writing, and that's fine. Okay. All right, so now what I want you to do is you can use the line tool, or it's really kind of a short little line segment, so you don't necessarily have to. I'm going to, those just so my picture looks better for you. Because I don't have a triangle for you to drag and drop on this, we're going to go ahead and complete this pi 6 triangle. So I'm going to just drop a perpendicular line down to the axis like so. so that I have my triangle. And I'm just going to draw over the other ones. I don't know that you're even going to be able to tell I'm doing that. But so now I have that purple triangle right there. I don't care about it being filled in or anything. Just want it completed. So this is a right angle. This is my theta, right? In this case, it's actually pi 6, but it's an angle, it's theta, right? And so if theta changed, what's going to stay true about this triangle is that this is my x value, this is my y value, right? And then the hypotenuse is 1. All right, so let's start looking at why we care about this stuff. Let's talk some trig. We know that sine theta is opposite over hypotenuse. We all agree with that? So what that means in this triangle, this is my theta, the opposite is y, the hypotenuse is the radius. The measurement for y is going to change as we go around the circle. Does the radius change as we go around the circle? No. So that really means that this equals y over 1. So in the end, guess what? Sine theta equals y. That's a huge deal. You know why that's a huge deal? If I say, what is the sine of pi thirds? It's the y value. Pi thirds, the sine of pi thirds is the y value, square root of 3 over 2. The sine of 7 pi 6 is negative 1/2. It's whatever that y value is on a unit circle. If it's not a unit circle, then it's y over whatever the radius is. But in this case, our radius is going to be 1. This gives us all of those values. So if we look at cosine, we know that cosine theta is adjacent over hypotenuse. Right? So that means this is theta, my adjacent is x, hypotenuse is the radius. Since I'm in a unit circle, the radius is 1, so that's x over 1. So that means that cosine theta is the x value. Everybody with me so far? So if I ask you, what is the cosine of 5 pi 6, your answer is negative square root of 3 over 2. The cosine of 2 pi thirds is negative 1/2. There are all those values that you need to know. Because remember I said you're going to have to just know what is the cosine of this, what is the sine of that. So your ordered pairs on a unit circle are cosine theta, sine theta. And this is going to start making some of your AP physics stuff make sense why you were doing what you were doing with some of your m cosine theta, m sine theta stuff. We'll get to that and I'll explain that a little bit. All right, so that's cosine and sine. Let's talk about tangent. So we know that tangent theta is opposite over adjacent. Right? Well, tangent theta is y over x, right? Because that's opposite over adjacent. So I can say that tangent theta equals y over x. But I can take it one step further. Because what is y in my unit circle? What do we box right there? Sine theta. So that means tangent theta is sine theta over cosine theta. Sine over cosine. Y over x. Rise over run. Everybody good so far? Okay, so I was going to take one more thing on here, but I did that last period, and I feel like maybe it was just too much information all at once, and I don't think they got out of it what I was trying to get out of it, because it's just like information overload. So I'm going to pause on it, because we're going to open both of these things back up tomorrow when we continue to talk about this, because we have a whole lot more to talk about with this. But I just want you to see, first of all, these patterns, and how if you had to fill it out again, you could fill it out again, right? But you're not, again, not always going to be filling out the whole thing. Tomorrow we're going to talk about how you could just know parts of it without having to picture the whole thing all the time. I want you to understand that these values are on here. So if I ask you, what is the sign of negative pi 6? Negative pi 6 means I rotate this way, so this would be my negative pi 6, right? So sign would be negative 1/2. I did put an assignment in Delta Math. I started not to put anything, but I did because it's very simple. I want you to have this open and or the other one open in front of you when you do it, and I realize on a screen you might have to click back and forth. But it's going to ask you, what is the sign of pi thirds? What is the sign of 2 pi thirds? Whatever. And it's going to make you draw the angle. So it's going to make you, like, if it says 2 pi thirds, it's going to make you draw this angle and then figure out the sine or cosine, and you can just pick it right off the picture. You're not always going to be able to pick it off the picture, but right now I want you to do that so you understand that that's what those values are. Does that make sense to you? Do you feel confident enough that if you had this sitting in front of you, you could tell me the sine or cosine of each one of these angles? We're good? You're just picking them off the ordered pairs. And there will be negative angles in there, but just remember that that means you go this way, and you have to figure out where you end, okay? And it will lead you through it. I really think that it would help you. Yes, you still have 2 days for it, but I really think it would benefit you if you at least did some of it before you came back tomorrow, okay? Because this takes a while for it to kind of, like, it's going to have to marinate in your brain a little bit, all right? I don't expect you to have anything memorized tomorrow. Don't try to memorize anything, but just an understanding of it for you to be exposed to it, and then we'll get you there, okay? Any questions at all? All right, and again, we'll open both of these back up tomorrow, so make sure you know how to reopen the activity we did. You don't want to have to click on the link again because it's going to give you a clean copy. So make sure you can find it in your Google Drive, okay? All right, so you have a few minutes left.